Start into 2, 4. We were working with imaginary numbers. What's an imaginary number? I
is -1 squared. No.
So I is the square root of -1, yes? If you go back to yesterday's notes, I is the square root of -1, and I squared is? Just -1. Okay, so we were in the process of dividing, and we had completed A in your class, and we were getting ready to do B. Okay, what was the rule here? We have this fraction, and there's an I on the bottom. What do we have to do?
Conjugate to the
Okay, we're going to multiply by the conjugate. What is the conjugate of the denominator? So what is the conjugate of -1 plus 2i?
1 minus 2i.
Only change one sign. -1 minus 2i. So you only change that sign in front of the I. What I multiply the denominator by? We're going to multiply the numerator by. How do we multiply these numerators? We are foiling, aren't we? Okay, so FOIL with me. 4 times -1. -4. 4 times -2i. -8i. Insides. -3i times -1. Plus 3i. And -3i times -2i. 6i squared. Okay, FOIL the denominator. -1 times -1. -1 times -2i. Plus 2i. 2i times -1. Minus 2i. 2i times -2i.
Wait, no, -4i.
About -4i squared, yes? Watch these signs right there. It's one of these things, there's so many little places you can make a mistake, so be very careful. Okay, let's do some cleanup, yes? I don't know, what do you guys see?
2 i's cancel out.
Okay, so as we start looking at i's, 2i minus 2i will cancel, which is what should happen in the denominator, yes?
Yep.
What else do you know? Okay, on the top, -8i plus 3i is going to give me -5i. We still have a -4 out front, yes? What about 6i squared? What do you remember from yesterday? Yeah, I squared is -1, yes? If I squared is -1, then this becomes 6 times -1, which is what? -6. Okay. If you went ahead and cleaned that up, that's awesome. I'm not spacing this right. Okay, let me go ahead and do the denominator. What do we know of the denominator? There's a 1. What about -4i squared?
Plus 4.
It's going to be -4 times -1, which is going to make it +4. Okay, now, clean up. On top, what do I have? -4 goes with -6, which is -10. Still -5i, all divided by 5. Can I go farther?
Yes.
Yes, you should. You can't always, and I'll demonstrate that in the next one, but we should go farther here. Think of this, 5 is dividing into both pieces, right? -10 divided by 5 is 2, -2. -5i divided by 5 is -i. So final answer of -2 minus I. Okay. So, C is good practice here. You tell me. How do I start this problem?
Divide or multiply by the conjugate.
And what is that?
3 minus 4i.
Okay. Multiplying by the conjugate of the denominator, which you just changed that middle sign, and so it's 3 minus 4i. What I do on bottom, I do on top. Yes? And again, on both top and bottom, we are FOILing. Okay. Okay. 5 times 3. 5 times minus 4i.
Minus 8i squared. Wait, I don't know what I'm missing.
I'm at minus 20i. You're on a different spot. And you can do them in any order. Or maybe you're just ahead of me. Okay. Negative 2i times 3. Negative 2i times 3.
6.
Minus 6i. Negative 2i times negative 4i.
Plus 8 squared.
Plus 8i squared. Okay. Denominator. I'm just going to FOIL. If you want to take shortcuts because you see something that's going to happen, more power to you. 3 times 3 is 9. 3 times minus 4i, minus 12i. 4i times 3, plus 12i. 4i times negative 4i. Minus 16i squared. Okay. There are some things that should happen, yes? What kind of things do we see happening? Oops.
Pick up 12, then add your i's on top.
Okay. Negative 12i plus 12i are going to cancel. On top, negative 20i minus 6i is going to be
negative 26.
minus 26i. If I work on that numerator, I also have a 15. And what about this plus 8i squared? Yeah, it's going to end up being minus 8 because I squared is negative 1, and 8 times negative 1 is minus 8. In the denominator, we have the 9, and what do we know about the minus 16i squared? It's going to be plus 16, isn't it? Because that I squared is negative 1. So we're going to end up with 9 plus 16. Okay, do some math here. What can I finish up on top? Okay, 15 minus 8 is 7. Then we have minus 26i. Denominator, 9 plus 16 is 25. Now, what's different about this one from other ones? Yeah, we can't divide this, can we? 25 and 7 don't have any common factors. 26 and 25 don't have any common factors. Now, officially, your directions are always going to be right answers in A plus BI form. So, and I don't know, again, didn't think to check if Savas will require it, but split this into 2 is your best bet here. If we're looking for A plus BI form, because right now that A plus BI form is kind of smushed together, but this 25 goes with every term in the numerator. So I can rewrite this as 7 over 25 minus 26 over 25, and the I it has a choice. The I can either be in the numerator with the 26 or beside the fraction. The I cannot be in the denominator with the 25. Okay. Now, D, kind of a special case. And we have options. You have options. Thoughts? Guesses? Yes.
We just divide 12 by 3. 3 by 12, whatever.
Well, the problem is you also have to do 9 divided by 3i. And while 9 divides by 3 nicely, you still have that I in the denominator that would not work. So we're still going to use the idea of multiplying by something. What'd you say?
Negative 3.
Okay. Could we multiply by negative 3i? Okay. One option, and I'm going to give you a couple here. If you think of 3i being 0 plus 3i, what would be the conjugate of 0 plus 3i? 0 minus 3i. So does multiplying by minus 3i make sense?
Yeah.
Okay. And I'm perfectly fine with that. The only thing is we're going to have some simplifying when we get done. That's fine. Our job is to just get rid of the i's, yes? Multiplying by negative 3i would give me negative 9i squared. I squared can go away. There's a smaller option, because really we just need I to go away, right? And so what were you suggesting?
Just throw the I over.
Yeah. You have an option, okay? Both of these are good options. You could just multiply by I. Now, I'm not saying you have to, but if you multiply by I, just think ahead. Does that work? 3i times I is going to be 3i squared. We know I squared will be negative 1. Our i's are gone, yes? And that's the whole goal. So you could multiply either or by I. I was originally suggested negative 3i, wasn't I? You can multiply by positive 3i if you want to, okay? Those are choices, okay? Any of them will work, any of them will get you there. You just have to be able to make sure you reduce in the end. Does it matter which direction I officially go?
Let's do negative 3.
You want to do the negative 3i? We can, because I'll be able to demonstrate the reducing. Now, if you're sitting there saying, oh, Mrs. Sargent, I already went through and multiplied by I. Meet me at the end. Okay? Meet me at the end. Okay, I'm going to rewrite that. That looks... Okay, we're multiplying by negative 3i. What we do on top, we do on bottom, right? So, on top, what do we do with this piece? You're going to take the negative 3i and distribute. Negative 3i times 9 is going to be
27.
minus 27i. Negative 3i times 12. Okay, I'm going to write it as minus 36i squared. In the denominator, you're just multiplying 3i times negative 3i, so we have negative 9i squared. Okay, I squareds are going to change to negative 1s. And so when the I squareds change to negative 1s, I now have negative 27i. Instead of minus 36i squared, it's going to be plus 36. Instead of negative 9i squared on bottom, it's going to be 9. Now, if you multiplied by just the I, then you don't have as much to reduce, I think, if I recall. But you still have a little to reduce, so. Negative, well, okay, wait, what do you know? Everything can divide by the denominator, yes?
Mm-hmm.
So do it. Negative 27i divided by 9 is negative 3i. 36 divided by 9 is plus 4. So I have negative 3i plus 4, which is also written as 4 minus 3i.
It doesn't matter anyway.
Officially, if they say a plus bi form, 4 minus 3i is your official form. Negative 3i plus 4 is equivalent. I don't know, they sometimes just get nitpicky in this situation. Okay? Okay, guys. This is probably the tough part of the lesson, in my opinion. Okay, this is the part that you guys are gonna get into homework, get to review worksheet later on, and you're gonna forget what to do. So this is the part that we're gonna have to work to make sure we understand. The bottom part is solving equations. Now, if you're sitting there saying, no, this is gonna be a tough part. No, I don't think it is. I think you're gonna like this part. Okay? So, the question is, how can you use square roots to solve each equation? Okay? We're gonna do more of this as the chapter goes along. But x squared equals negative 16. Our goal is to solve for x. How do we solve for x when there's an x squared?
Square root.
Square root, right? When you have just an x squared in a number, one option is to get the x squared by itself, move the number to the other side if you need to, and take the square root. If you take the square root of the left, you take the square root of the right. What is the square root of x squared? It's x. Now, we're taking the square root of negative 16, yes? I'm going to leave that under the radical for a moment. We're going to talk about what that becomes. But what do we have to remember when we take a square root in an equation setting? I don't know that we've talked about this year. When you take a square root in an equation setting, what do we have to put in front of that radical?
Negative.
How about both? Plus or minus. Okay? So, if you're just normally taking a square root because you see a radical sign, you just give me whatever goes under the radical sign. But if you're in an equation and you're solving, and your step is to take the square root of both sides, then you need to put a plus or minus there. Now, let's clean this up. We're going to have a plus or minus. What do you know about negative 16? Okay. The square root of 16 is 4. What about the negative? The square root of the negative 1 is I. You remember doing this yesterday? Okay. So we can think of our answers as plus or minus 4i.
Yeah, I don't like this.
You don't like this?
Alright.
Okay.
I think Adam beats it.
Everyone's entitled to their own opinion. Obviously, you disagree with my opinion. Teach their own. Okay. So, we are going back and simplifying square roots like we did at the beginning of the lesson yesterday, but I felt like you guys were okay when we walked away on that one, so. Okay. Let's look at B. 4x squared equals negative 36.
So you under 4, 5.
Okay. I would always plan, if you can, to get the x squared by itself. That's going to always be my suggestion. If you can get the x squared by itself, do it. So now, if we divide that 4 away, I end up with x squared equals negative 9. I have x squared equals a number, so now I can take the square root. The square root of x squared is going to be x. What about the square root of negative 9?
3i.
Okay. So we're going to have to say plus or minus, yes. And then negative 9 can be broken into what parts? Negative 1 and 9, yes? And I don't know if you still need to see that. Maybe you don't. And that's fine. Put this all together. Plus or minus. Square root of 9 is 3. Square root of negative 1 is
It's
I. So plus or minus 3i. Okay. C. What's my first step here?
Like a line, I was just trying to see that.
Let's go the other way. Subtract the 75 over because we want x squared to be by itself, right? So since it's plus 75, we're going to subtract 75. Then I end up with x squared equals negative 75. Once you have x squared equals, you're going to take the square root. Square root of x squared is x. Square root of negative 75. What has to go in front? Plus or minus. We know there is a square root of negative 1 there, yes? What do you know about 75? Okay. It's not a perfect square itself. You put it on the calc there, you get a decimal. I don't want decimals. Okay. But within 75 is 25, yes? If I have 75 cents in my pocket, I have 3/4 in my pocket most likely. And quarters have square roots. Okay? So I see 75 as 25 times 3. Remember doing this yesterday at the beginning of class?
Yep.
We took those radicals. If it's not a perfect square itself, look for perfect squares. Okay, so x equals plus or minus. What do we have here?
25 turns into 5, and then we have 5i square root.
Okay. Square root of 25 is going to turn into 5. The square root of negative 1 is going to turn into I. And the square root of 3 is going to stay square root of 3. Yes? So when you put those all together, we're going to have plus or minus 5i square root of 3. Okay. Could you have something where there's no perfect squares involved in this situation? Sure. That's possible. Okay. One more. D. Okay, we're working to get x squared by itself. So we're going to subtract the 25 over. I like it. So then I have 9x squared equals negative 25. Okay. I'm still working to get the x squared by itself, so we're going to divide by 9. And I'm going to have x squared equals, do 25 and 9 divide? No, so it's going to be negative 25 ninths. Don't tune out. Yes, it's a fraction, but it is no more difficult than any other problem we've done today. Okay. What's our next step to solve for x? Take the square root, yes? Okay. If we take the square root of the left, we take the square root of the right. Square root of x squared is x. Taking the square root in an equation setting, we're going to have what? Plus or minus. Now, do you see this? 25 is a perfect square. 9 is a perfect square, and there's a negative in there, yes? So think about this, if you want a visual. Square root of negative 25 is going to be negative 1 and 25. Square root of 9 is your other piece. Those are your pieces if you need to see the pieces. So, plus or minus, the square root of negative 1 is I. The square root of 25 is 5. The square root of 9 is 3. I wouldn't write it like this as a final answer. Right now I have I times 5 over 3. I would write this as plus or minus 5/3 I. Again, with the I, what I said earlier stands. What are your options for placement? Beside the fraction bar or in the numerator. Not in the denominator. That will get you wrong. And I assume Savas would accept either or. I guess I don't know that, but I'm assuming. Okay, guys. You have a homework out there and available if you haven't looked at it. Lesson 2.4 in Savas. I can't remember if this is the homework that was a little bit longer. It might have been.
Yes, 22 questions.
Okay. It's a little bit longer, but there were a good handful of like adding and subtracting type ones. Okay, so this homework is due tomorrow.